ยอดชีพ
จริงๆเลย
แรกลูกนี่คืออะไรบทบาทของรถ
ไม่เราเป็น
Hello everyone. We are the Crazy. In Thai name is Tini. Yeah. Today we would like to talk about the Park Nguyen Weir and on the Thap Salau Reservoir project and the Thai Thani province. So we find out the problem. We find nine main issues. The first of the problem is like sedimentation, and then we have a problem with the bank erosion, and the people in this area find out the water storage, and the new problem in this area is old and broken. And then we have the problem with the water management and water quality. And in the dry season, in this area is down. And rain season, this area is have a lot of side flow and the floods. And the last of the problem is the water user is conflict. And we use the NBS as a technique solution, working with the nature, not against it, to treat water, reduce sediment, manage flow, and at the same time strengthen the community and reduce water conflict. This is the master plan to introduce 7 key solutions. The first one, the community vegetation strip, and we have the sport court, like a football and the volleyball. And the third one, we have the learning space and playground. And the old weir and the new weir. And we have the Zen garden and the cafe shower. And let me show you about what we do.
Right. So we got like so many problems. So then how do we respond to that? So first things first. Okay. In our project, we implement the ideas of ecological corridor. So you can see from the small figure here, right? So let's go back. Yeah, you can see from the small figure on the top right here that we plan to have more vegetation along canals. So it's going to be like green corridor and like a little bit black along canals. So what's the benefit of this? So with this, we can solve the problem of illegal water uses. Because our corridor will act as a fence to prevent intruders from entering our land. But what is the definitions of ecological corridors? So ecological corridors along canals are linear habitats, such as riparian vegetation, wetland, or green belt, that being fragmented landscape to facilitate wildlife movement, improve water quality and enhance urban biodiversity. So basically what we are doing here is like turning this canal, just the soil canal, into something more cleaner and more pleasant to look at, like this. So what is the benefit? Why do we change to this? So the benefit of it is like it's provide habitat to fauna and fauna. It also solves the problem of water quality by filtering pollutant and sediment. It adds urban connectivity and reduce urban heat. And it also, we can like choose the right plant to claim the carbon credit back. Yeah. Let's move on. So what are we doing next? We try to improve the adjacent area of the original canals. This is the cross section of the original canals here. Actually, we don't touch the shape of the canal at all. So the shape of the canal will be the same. You can see from the figure here. Yeah, that's not bad. It's almost actually the same. But we play with adjacent area. You can see from the figure that we just expand the adjacent area here to make it more like flat slope, and then we can plant more vegetations. And it's not gonna, it doesn't need to be like 7 meters. You can just vary the space here to match with our boundaries. Yes. So what are we achieving by doing this? So the first thing is we can like improve the capacity of our canal to roughly around 36%. Yeah, you can see when the water fill up here. So it's going to help to mitigate the flood and side flow problem that we already have, right? And with the vegetation planting, it can help with the soil erosion along the embankment and drought because the plant will retain the moisture in the soil, right? And the plant will also expand their root into the ground to like increase the slope stability of the soil. And in addition, it can also reduce the water loss via water supply because we got more time to like, retain more water.
Oh, sorry.
The cascade very
Next, we're gonna talk about wetland and new year. We're gonna design new year to be like a piano key. Okay. So as you see from the scheme, the plan view of the linear, typical linear weir is just like a step line. Its physical width in the channel is exactly equal to its effective piercing. Okay. But when we look at the plan view of the piano key weir, it shows a repeating key patterns. Because of this force, it can provide an effective length that is like 2 to 4 times greater than its physical channel width. So if we paste this to this, we're gonna have like much more effective length area. It will like reduce the hybrid base of it. So you can like it's making a deal of So it's making a deal of like fragmented. Okay, and then you need rectangle shape design allow them to fit in the confined area. So we can have like a wetland park on both sides of the embankment. So have that and connect with the pedestrian bridge. Yeah. Okay, and we will also gonna make like a double vertical gate inside the beer to control like quantity and quality of the water. So if we want to reduce some sediment, just lift the first gate up, and if like when it is the dry season, just reduce the second gate to make the water flow. Next slide, please.
to deal with the sedimentation problem. For the mostly in this slide, face the sand accumulation in the canal. So that we propose some kind of community power smart sediment management system into this design. For the first one is we will expand the cross section before going to the ozone. Before in upstream before going to the new area to create like the steel basin. We put this because to reduce the flow velocity and let the sediment set up in the bed by the gravity, and then we create a slope jump into the sedimentation chamber near the canal. And this show the section of the some chambers. We have the slope here to let the sediment go to the chamber, and we put two pumps in the different level. The first one is in the place located on the base in order to pump the sludge or the sedimentation out from this chamber. And for the other one, in case of when we need to like the flush the sediment more to this chamber, we will close the gate and then use the pump that located above the sediment and pump the water out to create a hydraulic water hydraulic head different, and then open the gate to like a spot to drive the sediment go to the this chamber and pump it out. For the power supply, we put the solar panels connect with the battery and also the bicycle generator to let the people in the community can join to participate in this system and learn about the renewable energy. Next slide, please. And before we go to what we design in each zone, just recap a little bit for our master plan. Master plan we will divide it into three parts. The first one zone is here is mostly for the community vegetation strip, and for the zone 2, it is we are located here. We will demolish and create the beach instead, and the new area is located here in number 5. And we have some activity here to boost up both mental health and physical health. Mental health like Zen garden here. The people can meditate and play around here, and we have the Spartan race to improve the physical health. And last one is zone 3. It is the sport court, and we also design for like the retention basin. And Nopano will
for Zone 1. This zone is a community vegetation strip and learning space playground. The slope become a community strip instead of being a barrier. It is designed as a layer of landscape that integrate planting, sitting, and play. People can sit, learn, integrate with nature, while children play through nature elements embedded in the terrain. This area also functions as an ecological buffer, helping slow down water, reduce erosion, and improve biodiversity. And in the second zone, the slope shifted into more calm and contemplate experience. The Zen garden, designed with a simple material like gravel, stone, and sand from sedimentation that Pinat has said, create a peaceful atmosphere. The cafe position overlook the water, encouraging people to slow down and connect with landscape. The outdoor shower is integrated naturally into a Sparta activity. So when they do a Sparta, people come to the cafe and then run,
Yeah, this is
run
Spartan.
run to the wall, take all the sand and gravel, go to the next station. And then when they're really tired, they go back to the cafe, take some shower, eat, and spend money. And next one.
Okay, next is Zone T. Located in project right of way on the right side of the river, downstream of the area. This area is developed as a canal side landscape by integrated environmental concept with public space design. The special elements are arranged to create a connect between water, in space, and community activity. Key features include a football field and beach volley court, which utilize sediment sand from the river. In addition, the area serves as a water storage space during the dry season in the outlet from the river. And as a flooding basin during the wet season. Okay, next slide. The Guinea project focus on developing canal side area through the integration of private backbone, being an air infrastructure. As a result, the project not only improve water management, but also enhance environmental quality and promote the overall well-being of the community. The project represents phase 1. In the future, may be extension upstream and downstream that on community needs and safety, ensuring continuous and sustainable development.
So, thank you.
So NPS is not only an environmental result, it is also a social solution that connects people, water, and the landscape together. Thank you.
Can we go back to the plan? One of the plan. Well done, young team. This.
Hello. Great. There's a lot of really good ideas in this design that I want to share my feelings. The first one is the fact you call it a corridor. Right? So immediately you see the difference between team's design. This design is that they are now seeing the whole thing as a corridor. By breaking the levees, so they push the levee out all the way to the red line boundary, right? So all the land is currently a truly floodable floodplain, basically. So that's the two different designs. Both of them are really good, but the design they call corridors, they understand the meaning of corridors by pushing the boundary all the way out. So that's a great idea. And the second thing I said, really pleased to see the double vertical weir, right? That's exactly what we're looking for. Right? So the double weir basically saying, we have the flexibility to discharge water either from the top or from the bottom. The top one can also help to manipulate water levels across the city. That is what a modern weir needs to look like. And if you can also think about, if you can, through some mechanism, to be able to discharge water from the middle of the water column. You now have the top, then you have the bottom, right? And then maybe somewhere in the middle. So think about the intake in the typical water intake tower in a reservoir. So the idea why we make an effort to do this is because by discharging water from the bottom, the sediment can flush out. On the top, we have clarity, have a clear water on the top. But in the middle is when we have algal bloom, a lot of aquatic plant float on the top. Right? Then you want water free of algae, then you discharge water from the middle. So think about that. Then you truly have a water weir. Because this is what the water supply tower use all the time. Okay? But I don't think it's difficult to do. Just think about that. And I love the pumping idea, right? So basically people riding a stationary bike, they take the sludge out, right? So why not, when you are pumping this up anyway, and the sludge, I think 70% of that sludge, which is the water mixture with sediment, it needs to be dewatered. So maybe you pump it anyway, maybe you pump it to the starting point of the well, and let the sediment settle and water go through that. Because you pump it anyway, you lift it up anyway. And the majority of what you're lifting up is actually water. Okay? So you separate water from the sediment. So that's something to think about. Zone 1. Zone 1 is great. Because now you're taking effort to integrate that to the existing park. So community see, okay, wow, we're doing something that help us to upgrade the park facilities, right? And you give the people the opportunity to participate in agriculture, farming, right? As part of the park. So that's a great idea. And the startups really important to see. I think the young people love it, right? You basically subcontract maintenance to the community, right? Why not? And then you create more revenue for the cafe. And you guys going to run the cafe? Because you guys really benefit from this, right?
We do free labor.
Free labor, yes.
Because they can like transport the sand and sediment for us, and they have to pay us.
Maybe you could create some, like a credit notes, right? If you don't want to spend money today, but you can come back and spend money later. The other thing I want to talk about is, I'll go back to the water tanks, right? It is really important to think about how you use the water tank to store water during flood season and use it during dry season. Why it is important for this team is because you have a big soccer field and nothing underneath. So that could be a perfect place to put a water tank. And why is because now you design the whole thing as a floodable landscape. It's part of the floodplain. It's going to be very muddy after flooding season for the retirement basin. Think about that. Then what do you do? Right? What do? You have to use water to clean it. Right? So if you want to refine the design, it's good to have a wetland and an outlet and a water tank beneath the soccer field. So post the flooding season, you can spray, you can wash the mud away. But as you flush the mud away, you have something to treat that water before it goes back to the canal. Right? So think about that as a treatment train. like the first team, which team? The team who has a wetland after the water play. So same idea. So the other thing I want to talk about is, this is for everybody, every team, is that the survey shows it's a sandy soil, right, across this corridor. Think about, and we have so many sediments, and everybody's trying to deal with sediment problem. Can we use the in situ soil, not soil, in situ sand, and convert that into sand filter? Think about this, right? The dry weather flow channels, right in the middle, that's the majority of the flow is going through. So you will simply build a check dam, not a big one, but a small one, just wide enough to capture the dry weather flow, and build the water up. What happened then is it forced the water to go down through the sand, and it will daylight it somewhere at the downstream. Right? So you have in situ sand filter every intervals. You do nothing just by building a small check dam. So think about that. And what happens when the sand filter clog is even better, because you have less loss through infiltration into the ground, right? So you think about this, if you release 1,000 cubic meters per day flow downstream, at the very downstream, how much you could get? Maybe 30% loss through infiltration and evaporation because of sandy soil. So think about that. So by having to convert an existing dry weather channel into a sand filter, at some point, it will help you to retain the drop off the fine sediment, and then potentially increase the flow downstream, potentially. Okay. So think about that. Okay, is everything happy? Great. Well done, Dima. Thank you.